Hello, welcome back once again. Today we have this interesting Olympiad mathematics problem. We're given the following equation: x squared minus y squared is equal to 36, and here we're going to find the x and y values. This is just one equation with two different variables, and we're asked to find the value for x and y, given that x and y are integers. Is that possible? You need to know that this kind of equation is called Diophantine equation. We can do this, right? So from the left hand side, remember that is the difference of two squares, right? So we're going to use the formula that will be x plus y multiplied by x minus y, right? So this is equal to, from the right hand side, 36. Remember, we're solving for integers x and y. Now 36 is equal to, so 36 is equal to 1 multiplied by 36, right? Is also equal to 3 multiplied by 12. Is also equal to 4 multiplied by 9. Oh, we missed 2, right? So it's also equal to 2 multiplied by, is that 18? Yes, right? Any other one is also equal to 6 multiplied by 6. Think we're done, right? Then for negative, that would be negative 1 multiplied by negative 36. Negative 3 multiplied by negative 12. Negative 4 multiplied by negative 9. Negative 2 multiplied by negative 18. Negative 6 multiplied by negative 6. Wow. So we have so many cases here, right? Now let's solve this problem. So our first case here, that is our case 1. First of all, let us take note that for integers x and y, we know that x plus y is greater than x minus y. So let's take note of this, right? Then in our case 1, we're going to make use of 1 and 36. So we're going to equate x plus y equals 1 and x minus y equals, we're going to equate this 36. I don't know what is wrong with me today. Then this one here, 1. Sorry for that. Okay, so we're going to equate x plus 1, 36, and x minus 1, 1. So here, we're going to solve this equation simultaneously. So if we add both equations, y will be eliminated. Then we have x plus x, which is 2x. So this will be equal to 36 plus 1, which is 37. Divide both sides by 2, then you will see that x is not an integer here, right? So this case is not giving us our solution. Then let's go to case 2. So our case 2, we're going to use 3 and 12. So you know x plus y will be equal to 12, and x minus y will be equal to 3. So add both equations. X plus x is 2x. So this is equal to 12 plus 3 is 15. You will see that if you divide both sides by 2 here, we see that 2 is not an element of integers. That is not an integer. I forgot to put that here, right? So we don't have integer solutions here. So let's go to case 3. So our case 3, we're going to use the next 4 and 9, right? So now let's take note of something here to avoid all these unnecessary steps and cases here. So if you add the two numbers, if they're not giving you an even number, then we are not going to have integer solution. You should understand what I mean. For example, the first case, we have 1 plus 36. This is odd, right? So there is no integer solution here. 3 plus 12, that is the second number there. That will be 15. We don't have integer solutions. 4 plus 9, this is equal to 13. we don't have integer solutions. So 2 plus 18 is equal to 20, so we have integer solutions here. 6 plus 6 is equal to 12, we have integer solutions. So the same thing implies for the negative numbers, right? So we know that the negative 1 plus negative 36 is equal to negative 37. So no integer solutions here. So the only one left will be the negative 2 minus 18, which is negative 20, and the negative 6 minus 6, which is negative 12, right? So obviously now we have just 4 cases to consider here, this one and this one. So now let's start again. So let's say our case 1. So we have that x plus y is equal to 18 and x minus y is equal to 2. So add both equations. So x plus x is 2x, then y plus negative y is 0, then this is equal to 18 plus 2 is 20. So divide both sides by 2, so we get x is equal to 10. Then what about y? Remember from here, y will be equal to 18 minus x. So remember x is equal to 10, so y here will be 18 minus 10, which is equal to 8, right? So here we have our first solution set. Then our case 2, where we make use of 6 and 6. So we know for x plus y to be equal to 6 and x minus y also equal to 6, so we know that either x or y, one of them must be 0, right? So now let's add. So we get 2x is equal to 6 plus 6 is 12. Divide both sides by 2 from here, we get x is equal to 6. For y, remember from here, y will be equal to 6 minus x. So here y will be equal to 6 minus 6, which is 0. So you can see we have our second solution set here, right? Okay, then let's make use of the negative cases here. Okay, so our third case here, or our case 3, where we have x plus y equals negative, that would be negative 2, right? Because negative 2 is greater than negative 18. Then x minus y is equal to negative 18. So adding 2 plus x is 2x is equal to, this will be negative 20. Then divide both sides by 2, we get x is equal to negative 10. And for this part here, we know y will be negative 2 minus x. Then y will be equal to, remember, this will be negative 2 minus 10, which is negative 2 plus 10, which should give us 8, obviously. So we have 8. Is that correct? Yes. Okay. Now, let's go to our final case. Okay, so let's go to our final case, but do not forget we still have something missing here. For this part here, if x is equal to negative 10 and y is equal to 8, yes, this satisfies our equation. Remember, x can also be negative 10 and y can also be negative 8. Remember, we have squares, right? X can be 10 and y can also be negative 8. But let's go to our fourth case, the final case here. So this is where x plus y is equal to negative 6 and also x minus y is equal to negative 6. So add, so we get 2x is equal to negative 12. From here, we get x is equal to negative 6 and y will be equal to, remember from here, y, right? So y is equal to 6 minus x, negative 6 minus x. So negative 6 minus 6 is 0. So here we get x is equal to negative 6, y is equal to 0. So this part here is with permutations, right? Okay, so here we have our solution sets for x and y. Sorry for that noise. You know, this is Xmas periods, right? So the first solution set we got. So let's go back and check. So we get 10 and 8. So we got 10 and 8. So the second solution set, we got 6 and 0. So we got 6 and 0. Then the next solution set, the third case where we got -10 and 8. -10 and 8 with permutations, right? And here the final case where we get -6 and 0, right? So remember our equation is x squared minus y squared, which is equal to 36. So, and we know that x is greater than y. It must be greater than y, right? Okay, but that will be greater than y when we have positive, right? Where x and y, when they are what? Positives, right? But if they are negative, x can be greater than y, or y can be greater than x. That doesn't matter when they are negative. Okay, so here, if x is equal to -10, y is equal to -8, that will satisfy our equation, right? Yes, that will satisfy our equation. If x is equal to 10 and y is equal to -8, that will also satisfy our equation. So here we have our solution set for x. Thank you for watching. Please do not forget to subscribe. If you find this video really interesting and helpful, don't forget to subscribe. Please like, comment, and share. Bye bye.